Welcome to this tutorial where I will show you how to make a magnet activated sound. Let's say a horn, a bell or a whistle. What's the problem we're having? When a train crosses the magnet in the track, the sound will only play for a very short time. Only the time the sensor is activated by the magnet. I'll demonstrate it with the simulator of ESU Lokprogrammer. So let's say I activate the magnet sensor for a very short time, like it's done by the train when he runs over the track. You hear a very short sound. That's not what we want. So let's open the first horn. And what we see here is a return path after the first init section. Fast exit. That's not what we want. So the return paths will have to be cancelled. What we'll do is take the blocks we need for the sound, copy them into an empty sound slot, like this one. And like I said, we will cancel all the return paths. So we have the mute block. That's the block where the sound begins, but in this state it's not activated yet. From the mute block, make sure the simulator is turned off, otherwise you can't add any transitions. So from the mute block we go to the first sound block. And when is this transition activated? Only when the function is true. From the init we go to the loop, and from the loop we go to the exit, and always from the exit we go back to the mute. That's also always true. When I activate it for a short time, we get this. Open the simulator. But it's still very short. What's the problem? When you look at the loop, we can't do anything in this block, and that's because it's a container that contains another loop. And within this loop, we see the problem we had in the beginning, the return paths. So what are we going to do? Very simply, delete all the paths. Also this one. And so stop the simulator, add the transition to stop, validate is a good practice. When you press validate, the software checks if everything is alright, all the transitions that are needed are there, and when it doesn't, it will give a warning. So I did validate and it works. It doesn't say anything. And we'll try what it does now. That's what we want. The full sound only activated with the magnet. When you want this loop to be even longer, again stop the simulator. You can add a few times of that it will loop 2, 3, 4, 5, but I think this loop is already long enough, so I'll let it at 1. And we'll do it also for the bell. Now this sound project has a sound slot with a special bell. It has the normal bell and an auto bell. The explanation what an auto bell is, you can read that here. It's activated together with the horn. We need the normal bell. I choose the bell 1. And now we see that this is almost what we want. So again, copy to an empty sound slot. I saw here that sound slot 28 is empty. Paste it. Remove the parts, the transitions, excuse me. Doing some cleanup. Add the first transition. Only true when the function is true. The others are automatically true. And again. And after the end or the exit, always go back to mute. Now, this is already a loop. So let's check this. And there's a problem. What's the problem? This is a loop that is continuously going to loop without an end. When it comes to this block, it will not stop. So, what do we have to do? Uncheck this and add a specified number of times it will loop. And you can do that in two ways. If you want it for a specified time that you have in mind, 2 times, 3 times, you can do that like this. Now it will always loop 3 times. What you also can do is let the decoder decide, doing some randomness, how many times it will loop. So let's say I want it to loop minimal 5 times and max 10 times. Validate this. Yep, that's okay. And now we can do a check with the simulator. That sounds very good. Notice that this was longer than the first one. Okay, so all we have to do now is go to decoder, function mapping, and we'll need to add the sensor or sensor input, sensor 1, that is coupled to a read contact. And when sensor 1 is activated as true, it will activate sound slot 2, so the horn sound. And again for sensor 2, so that's the second contact of the decoder and a second input, and that will trigger sound slot 28, where we made our own bell sound. And that's all. Thanks for listening, and see you in another tutorial.